Welcome to this class. Today we will be looking at the fundamentals of an atom, molecule, and ions. Just a recap of what we learned in the last class, that matter is anything that has got space and has got weight or mass. However, according to one Democritus in the 400 BC, that matter could be divided up to a certain limit, that it cannot be divided any further. At that stage where it cannot be divided any further or it is indivisible, that is what will result to an atom. This was called as the atomos, meaning that it cannot be cut. This Democritus theory was also confirmed, as we learned last week, by John Dalton in his many experiments of how elements join to form compounds or substances. And in this case, he found that they combine in specific ratios, what we call as like in the case of the electrolysis of water experiment, where to form water, you only need one hydrogen atom and two oxygen atoms. Without those two, it cannot be water. Therefore, in John Dalton's theory is that an atom can combine to form an element or a compound or a substance only at specific ratios, because elements, compounds, or substances are made of atoms. In John Dalton's theory, elements are composed of small indivisible particles, what we call as atoms. The atoms of a given element are usually identical, as we mentioned in the last class. They have the same size, the same chemical properties, and the same mass. But what are compounds? Compounds are a combination of atoms from more than one element. Then, how do they combine? They often combine in the form of a chemical reaction. And in this chemical reaction, it is only that the atoms are rearranged. They undergo rearrangement. They cannot be removed or they cannot be added. This is what we call as the law of mass conservation, where atoms are neither created nor destroyed. They are only rearranged in the formation of compounds or substances. For instance, in this case, an element X has got 16 atoms, and another element Y has got 8 atoms. The two combine to form an element and a compound XY. In the XY, only that the atoms of X and the atoms of Y are organized in an arrangement, but none of them is lost or none of them is added. This is the law of mass conservation according to Dalton's atom theory. After Dalton's atom theory is another scientist called Thomson J.J. discovered the existence of an electron in a cathode ray tube experiment. In this experiment, Thomson concluded that an atom has got smaller negatively charged particles that are called electrons. However, he also measured the mass and the charge of an electron. The charge was negative. The mass is what we will see further in this class. However, Thomson did not know how the electrons were arranged within an atom. Neither did he know that there was existence of positively charged ions in an atom, just as we had seen in the previous class. However, he believed they were all mixed throughout the atom. He proposed that an atom was circular and throughout it was positively charged. However, within it were spread negatively charged particles, and he assumed this scenario to be the same as the plums that are found in pudding or the chocolates that are found in chips. the chocolate chips that are found in ice cream. This is what we commonly refer to as the plum pudding model. After Thomson's experiment came one Robert Milikan, who used the Milikan oil drop experiment to measure the mass of an electron. In this experiment, he discovered that the mass of an electron was equivalent to what we will see later in this stage. But this still was not enough, as the Rutherford theory is what we followed, and this is what we looked at in our previous class, that he was one of the significant scientists who discovered the existence of electrons, protons, and neutrons. And to your surprise, he was a student of Thomson's, but he disagreed with the plum pudding theory and devised an experiment to assay the electrons and protons in an atom. In his experiment, he found that 3 rays can be emitted by radioactive materials. This could be alpha, gamma, or beta. And in this separation of the rays to alpha, gamma, or beta, that is why the atoms were subdivided into their various sub-elements, what we call as the positively charged protons and the negatively charged electrons. This was done after using a lead block and putting in a radioactive element. Rutherford also conducted what we commonly refer to as the gold foil experiment, and in this experiment, he used several aspects to discover that atoms had a positive charge that was concentrated on the nucleus and mostly consisted of protons. However, he also discovered that they had some negative charges, which were known as the electrons. The mass of the protons was 1.67 times 10 to the power 24 grams. That was in his gold foil experiment. The interpretation of the gold foil experiment was that most of the particles traveled straight through the golden foil. However, a few of those were deflected while others bounced back. When they bounced back, what resulted is that most of the positively charged particles which are consisted in the nucleus, they went straight through the golden foil. Some of the positively charged were deflected or bounced back. Like other charges repel, so the nucleus must have a positive charge. This is what repelled with the electrons that were surrounding the nucleus and had a negative charge. Followed by the gold foil experiment was the Rutherford model that showed that an atom has got a central part which we called as the nucleus, and the nucleus consists of 2 elements, the proton and the neutron, both of which have got the same mass. However, the neutron does not have a charge, therefore the proton is positively charged and so is the nucleus. Followed by the Rutherford's claim was James Chadwick, who, in this case, tried to show that the relationship between the electrons, the protons, and the neutrons. In his experiment, he used the hydrogen and the helium. Hydrogen has 1 proton, while helium has got 2. The mass of helium divided by the mass of hydrogen ideally should be 2. The measured mass of helium and the measured mass of hydrogen is equivalent to 4. In this case, he discovered that the neutron has no charge, while the electron and the proton are negatively and positively charged respectively. Followed by Chadwick was the Bohr theory. which proposed that electrons that are negatively charged move in paths at certain distances around the positively charged neutron nucleus. These paths are what we refer to as the shells, the orbits, or the energy levels. And in this case, electrons can move from one energy level or one path to another as long as they have got enough energy. In the Bohr's theory, proposed that the electrons move in paths or certain distances that are around the nucleus, and they can jump from one energy level or one shell to another. The electrons travel in regions that are conclusively, after looking at all these theories, a new modern theory on the atom has been developed. And in this case, the electrons can travel in regions that are called electron clouds, and you cannot predict where exactly an electron is found or when it will be found. That is according to the modern theory of the atom after reassessing all the other theories we have discussed herein. But what are energy levels? The energy level is that part that can occupy a certain number of electrons. And usually, as we mentioned in the last class, is that the energy levels that are close to the nucleus are filled fast in comparison to those that are away. It is also noted that those that are close to the nucleus have less energy compared to those that are further. For instance, the energy level 1 here is filled with electrons first before the energy level 4 outside, on the outermost of the atom. Also, the energy level 1 here has got less energy compared to energy level 4. However, we also noted that the electrons can move from one energy level, that is from E1 to a higher energy level, or E4 to a low energy level, provided that there is enough energy. In this case, we are looking at an analogy of a bookshelf. In this bookshelf, each one of these shelves represent an energy level on an atom. And then each book within an energy level represents an electron. You can move a book from one energy level to another, or whether it is lower or higher, you can move a book or an electron from one energy level to another. But the electrons or the books cannot be between a shelf. That is, in each of these energy levels which are represented by a shelf, and in each of these shelves where each book represents an electron, you can move a book from one shelf either lower or higher, provided that you have got adequate energy, but the book cannot be in between one shelf and another. This is the same case with an atom. An atom can only be found in an energy level. And within this energy level, there are several atoms. The atoms can move from one energy level to another, either a higher energy level, a more inside to the nucleus, or a further outside to the nucleus, provided that there is enough energy. But an electron cannot be found in between one energy level or another. It is from these theories and these basics of atomic theory that we understand that there are three subatomic particles in an atom: an electron, a proton, and a neutron. This is their mass, as I had mentioned that we will look at it. This is their specific mass. And as we can see, the mass of a proton is equivalent to the mass of an electron. However, the mass of a proton and an electron is way much higher compared to that of an electron. Therefore, the unit charge of an electron is -1, or that of a proton is +1 and that of a neutron is 0 since it has no charge. A representation of an atom is that an atom is usually arranged in this, as we will see later, in a periodic table. It has got an X that represents the element smal, and the A that represents the mass number, and the Z that represents the atomic number. A recap from our previous class is that the atomic number is equivalent to the number of protons, and the mass number is equivalent to the number of the mass number is equivalent to the number of protons and the number of neutrons. The number of neutrons can only be found by subtracting the mass number and the atomic number. The number of protons, which is the atomic number, is also the number of electrons. However, in some specific elements, you will find that there are atoms of the same element that have got different number of neutrons in their nucleus. This is a case example of hydrogen. Look at hydrogen, this kind of hydrogen, and this kind of hydrogen, and this kind of hydrogen. In the first case, hydrogen has got an atomic number of 1, which is equivalent to the number of protons. It also has a mass number of 1. In the second case is that it has got the number of protons are 1, however, the mass number is 2, meaning that it has got 1 electron. It has got 1 electron and has got 1 neutron. And in this case, it has got 0 neutrons. In the third case is that the hydrogen has got the number of protons is 1, or the mass number is 3. In this case, it means that the number of neutrons are 2. This is the same case with uranium. In one uranium, we have got 92 protons, while in the other, with a mass number of 235, while in the other, we have got a mass number that is 3 neutrons higher, meaning that in the second kind of isotope, we have got 3 more electrons compared to the first one. Substances that exist they are of the same element but have got different number of neutrons are what we are referring to as isotopes. In a self-review, let us look at examples of other substances that exist as isotopes. The case is that of carbon. Carbon has got 6 protons. In both cases, it has got 6 protons and 6 electrons. However, when you look at their mass number, the first case it has got 14, meaning that it has got 8 neutrons. And in the second case, it has got a mass number of 11, meaning that it has got 6 neutrons. That will be the end for now.